Hello students, in this video we will discuss previous year questions and few important NCERT questions. These questions are very important for your board exam. We will not cover all the questions in one video, we will cover in different parts. This is the first part and we will start with circles and areas related to circles. Okay. First question. Two concentric circles are of radii 4 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. What are concentric circles first? Okay, these are two circles. One circle is inside another circle. Okay, and these two circles will have same center, that is O. Okay, and the radius of the bigger circle is 4 centimeters. We will take the radius of the bigger circle is 4 centimeters and the radius of smaller circle is 3 centimeters. Okay. The length of the chord of the larger circle, it touches the smaller circle. Okay. See the larger circle chord, the chord of the larger circle will touch the smaller circle. So this is the chord AB. Okay, we will take OA as the radius of the bigger circle, it is 4 centimeters, and we will take OP, the radius of the smaller circle, it is 3 centimeters. We have to find the length of the chord AB. We have to find what is AB here. OP is the radius. The radius is perpendicular to the tangent. See, AB is the chord for the bigger circle and AP is the tangent for the smaller circle. Okay, so radius OP is perpendicular to the tangent AB. So this forms a right angle triangle. Triangle OAP forms a right angle triangle and angle OPA. OPA is 90 degrees. This is 90 degrees. Okay. So by using the Pythagoras theorem, we can find the value of AP here. Okay. What is AP? What is Pythagoras theorem? It is hypotenuse square. It is OA square is equal to OP square plus AP square. OA square is 4 square is equal to 3 square plus AP square. It is 16 is equal to 9 plus AP square. 7 is equal to AP square. So AP is equal to root 7. Here OP bisects AB. OP is the radius and OP bisects AB. So AP is equal to PB. This implies PB is equal to root 7. So the length of the chord AB is equal to AP plus PB. It is root 7 plus root 7. It is 2 root 7. This is the length of the chord of the larger circle and it touches the smaller circle. Okay. Next question. An arc of a circle of radius 21 centimeters subtends an angle of 60 degrees at the center. Okay, we will take a circle. This is the center. Here the arc subtends an angle of 60 degrees. Okay, we will take the arc AB. This is the arc AB. This will make 60 degrees with the center. This is 60 degrees. Okay, here OB is radius and OA is radius. Radius is 21 centimeters. We have to find the length of the arc AB. In the first one, we have to find length of the arc. What is the length of the boundary of the full circle? Length of boundary of full circle is perimeter. Perimeter of the circle is 2 pi r. Right? So what is the length of the arc? Length of arc is equal to 2 pi r. Okay, the length of the boundary of full circle into theta divided by 360 degrees. So here 2 into 22 by 7 into radius is 21 into 60 divided by 360. Okay, 60 into 6 here, 7 into 3. Okay, 3 into 2 here, 2 and 2 will be cancelled. So the length of the arc is 22 centimeters. Okay, and in the second one, we have to find the area of the minor segment of the circle made by the corresponding chord. What is the chord here? See, AB is the arc. AB is the length of the arc. Okay, if we directly join A and B, this becomes a chord. Okay, so we have to find the area of the minor segment. See, this is AB. Okay, here if we join AB directly, we get a chord. And we have to find the area of the minor segment. See, this is the minor segment. It is the area between the chord AB and the arc. Okay, we have to find the area of the minor segment. How do we find the area of minor segment? Area of minor segment is equal to area of the sector. Okay, this full OAB, this full is the sector. We have to subtract area of the sector minus area of the triangle OAB. From this full sector OAB, if we subtract the area of triangle, then we will get the area of the minor segment. Okay, then we will get this one. Here we will find the area of the minor segment. Okay, for that we need to find the area of the sector first. Okay, area of the sector OAB. Sector area is equal to what? It is pi r square into theta divided by 360 degrees. Okay, it is 22 by 7 into radius is 21 here and the angle is 60 degrees. Okay, into 21 into 60 divided by 360. Okay, 60 into 6 here, 7 into 3, 3 into 2, 2 into 11. So the area of the sector is 21 into 11. It is 231 centimeter square. Okay. Now how do we find the area of the triangle OAB? See, if you see this triangle clearly, OA and OB, these two are radius. Okay, these two are radius. So this forms an isosceles triangle. Okay, so the angles opposite to the equal sides are equal. So we will assume these two angles as x. Okay, so if we assume these two angles as x, then we will apply the angle sum property. We will get 60 plus x is equal to 180 degrees. We will get here 2x is equal to 120 degrees. We will get x is equal to 60 degrees. That means every angle is 60 degrees. Okay, every angle is 60 degrees. Or you can directly consider this as equilateral triangle, because if the angle subtended at the center is 60 degrees, then the remaining two angles will be 60 degrees each. Okay, you can directly take this as equilateral triangle. So what is the area of the equilateral triangle? Area is root 3 by 4 into side square. Okay, it is root 3 by 4 into radius is 21 into 21. Okay, here you will get 441 root 3 by 4 centimeter square. Okay, now what is the area of the minor segment? Area of the minor segment is equal to area of the sector 231 minus area of the triangle 441 root 3 by 4 centimeter square. Okay, this is the area of the minor segment. Okay, next question. In the given figure, PQ is a chord of length 8 centimeters. See, PQ is a chord of length 8 centimeters. Okay, and the radius of the circle is 5 centimeters. The tangents at P and Q meet at a point T. See, TP and TQ, these both are tangents. Find the length of TP. We have to find the length of TP, this one. Okay. See, we have done this problem in previous sessions also. This is very important. And how do you do this kind of problems? See, if any side of a triangle is asked, then you have to apply similarity of triangles property. Okay. See here, OT is a line. It is joining the external point T and the center. So this OT bisects PQ. That means PR is equal to RQ. Here PR is equal to RQ because OT bisects PQ and the angle is 90 degrees here and angle PRO is 90 degrees. Okay. See, if PQ is equal to 8 centimeters, then PR is what? PR is half of PQ. It is 4 centimeters. PR is 4 centimeters. Okay. See, in triangle PRO, this is a right angle triangle. Okay. By using the Pythagoras theorem, we can find the length of RO. It is hypotenuse square. OP square is equal to PR square plus OR square. It is 5 square is equal to 4 square plus OR square. It is 25 minus 16 is equal to OR square. Here you get OR is equal to 3. Root of 9 is 3. OR is equal to 3. Okay. Now we will compare the triangles PTO and PRO. Okay. Okay. Now this OP is radius. OP is radius and PT is the tangent. Tangent is perpendicular to radius. So angle OPT is 90 degrees. Okay. Now we will compare these two triangles. We will compare these two triangles. In the first triangle PTO. Okay. Which angle is 90 degrees? It is P. Okay. And in triangle PRO. Which angle is 90 degrees? R. Okay. And angle O is common in both the triangles. O. Okay. And the remaining angle is T here. And here it is P. Now we have taken these two triangles in correct order. We have to take the triangles in correct order or else we will get the wrong answer. Now these two triangles are similar. Triangle POT is similar to triangle ROP. Okay. Now we will take the ratio of the corresponding sides. It is first two letters we will take PO divided by RO. Okay. Is equal to. We will take the next two letters OT divided by OP is equal to. We will take first and third PT divided by RP. Okay. Now here we will take PO. PO is 5 divided by RO. RO is what? 3. Okay. Is equal to OT. OT is what? We don't know OT. So we will not take this ratio. Okay. Next is PT. PT is what? X. We don't know. Next RP. RP is what? It is 4. Now what is X here? It is 20 divided by 3. That is TP. Okay. Next one. In the given figure, AB is the diameter of a circle centered at O. BC is tangent to the circle at B. If OP bisects the chord AD, this OP bisects the chord AD and angle AOP is 60 degrees. Angle AOP, this is 60 degrees. Find angle C. We have to find this angle C. Okay. Here OP bisects AD. Okay. So here we will join OD. We will join OD here. OP bisects AD. That means AP is equal to PD and angle AOP is equal to angle POD. Okay. This angle is 60 and this angle will also be 60 degrees because OP bisects AD. Okay. And OA is equal to OD because these two are radii. OA is equal to OD. So the triangle AOD forms an isosceles triangle. Okay. So the angles opposite to this equal sides. So angle OAD is equal to angle ODA. So the angles opposite to this equal sides are equal. This angle is equal to this angle. Okay. We will assume this as A. Okay. So in triangle OAD, we will apply the angle sum property. It is angle OAD. It is A plus 60 degrees plus 60 degrees plus A is equal to 180 degrees. Okay. We'll get here 2A is equal to 180 minus 120. It is 60 degrees. Here we got A is equal to 30 degrees. So in this triangle, this angle A is 30 degrees. Okay. OB is radius and BC is tangent. So OB is perpendicular to BC. So angle ABC is 90 degrees. And in triangle ABC, we will apply the angle sum property. We will get angle A. It is 30 degrees plus angle B 90 degrees plus angle C. It is X is equal to 180 degrees. So X is equal to 180 minus 120. It is 60 degrees. So angle C is 60 degrees. Next question. In the given figure XAY, it is a tangent to the circle centered at O. If angle ABO, this is 40 degrees, then find angle BAY. We have to find BAY. We have to find this angle and angle AOB. And we have to find this angle. Okay. See, OA and OB. These two are radius. OA and OB. These two are radius. These both are equal. So triangle AOB forms an isosceles triangle. Triangle AOB forms an isosceles triangle. So the angles opposite to the equal sides are equal. So this angle. So angle OAB is equal to angle OBA. It is what? 40 degrees. So this angle OAB, this is 40 degrees. Okay. Now in triangle AOB, we will apply the angle sum property. It is angle AOB plus angle OAB. It is 40 degrees plus 40 degrees is equal to 180 degrees. We'll get angle AOB is equal to 180 degrees minus 80 degrees. It is 100 degrees. Okay. Now, and OA is radius and XAY is tangent. So angle OAY, this is 90 degrees. Radius is perpendicular to tangent, right? So if angle OAB is 40 degrees, okay, then angle BAY is equal to angle OAY minus angle OAB. Okay, it is 90 degrees minus 40 degrees. It is 50 degrees. That's all for this video. We will continue the rest of the questions in the next session. Thank you.